All right. Hello, everybody. Welcome to the UMassSafe CV-STAC webinar series on innovative initiatives in CDL compliance and safety. Really nice to have you here. My name is Robin Reisman, and I am the director of UMassSafe. This webinar is part of our Commercial Vehicle Safety Technical Assistance Center, CV-STAC, and it's funded by a grant from the Federal Motor Carrier Safety Administration. This is the fourth in a 9-part webinar series. If you're interested in learning more about the next few webinars, feel free to go to the CV-STAC homepage. I believe the website is in the chat line. In addition, all the previous webinars are posted on the CV-STAC website. So if you missed one of the previous ones and you're interested in listening to that, you can go to CV-STAC and then go look under best practices. Just want to tell you a little bit more about CV-STAC before we get started. Want to encourage folks to go to the site and check it out. We have blogs there on a variety of topics. We have some best practice guides and some others on the way. We have the previous webinars, as I said, and lots of information from the 2016 CMV Summit. So we encourage you to go there often as we continue to update information on the site. So today's webinar is on improving commercial motor vehicle crash reporting and training of law enforcement officers. And we have Dr. Amber Brooke Trueblood and Dr. Eva Ship with us. They are from the Center for Transportation Safety at Texas A&M. I'm really excited about this webinar because this is a topic that's near and dear to my heart and that we spend a lot of time looking at in Massachusetts also. Amber and Eva are going to cover results from a Federal Motor Carrier Safety funded project with the aim of identifying underreporting in CMV crashes in Texas, as well as factors that were associated with that underreporting. Their discussion will center around results from a crash analysis to identify underreporting and associated factors, as well as a focus group with law enforcement officers to identify barriers to reporting, as well as potential solutions. So I think it's going to be a really interesting session for us today. After the presentation, there'll be plenty of time for questions and answers and discussion. If you have questions while they're presenting, feel free to type them into the chat line, and then we can get to those as we're able when they're finished. So before they get started, let me just tell you a little bit about our speakers. Dr. Ship is an injury epidemiologist, formerly trained in environmental and occupational health. She's a research scientist at Texas A&M's Transportation Institute Center for Transportation Safety, where she leads the crash analytics team. She has nearly 20 years of experience doing this kind of work, and since she's joined TTI 3 years ago, she's participated in a number of projects funded by Federal Motor Carrier Safety Administration and FHWA and the National Institute for Occupational Safety and Health. She's done a lot of work in this field and is a great resource. And with her, we also have Dr. Amber Trueblood. She is an assistant research scientist at the Crash Analysis Group at Texas A&M. She has experience in environmental, occupational, and injury epidemiology. She got her doctorate degree in epidemiology and environmental health from Texas A&M. And before that, she got a master's in public health, in health promotion and behavioral sciences from the University of Texas Health Science Center in Houston. Her areas of interest are in improving data collection and injury prevention. And she also has worked on a number of Federal Motor Carrier grants, FHWA grants, as well as Texas Department of Transportation grant projects in this field. So clearly they both have a lot of experience and some exciting information about projects there to share with us. So without further ado, here is Dr. Ship and Dr. Trueblood. Give them a minute to just get set up.
Good morning. It's actually just going to be myself, Amber Trueblood presenting. Eva unfortunately has a sick little one. So she is on the line for questions, but I'm going to actually be leading today. Okay, let's get the screen shared. So thank you, Robin, for that fantastic introduction. I hope everyone on the line has been able to join the other webinars throughout the series. It's actually a very interesting lineup, and I'm looking forward to the remaining several presentations. And we want to thank Robin for thinking of us and including us in the series. In the room, I have Dr. David Bierling. He presented, I believe, 2 weeks ago on his FMCSA project. He's also a project advisor on this current project, so he's here today supporting us. So let's go ahead and get started because I know many of you are here on your lunch breaks. So our FMCSA project focused on improving the collection and reporting of large truck crash data. And Chris, if I say Chris, it just means crash data. That's what Texas DOT calls our data set, and it's sort of ingrained in my brain. So I'd like to thank our project team. Eva Ship is our principal investigator. David Bierling, as I mentioned. We also had several other members here at TTI who helped with the data analysis and conducting our focus groups throughout the state. So to give a little background, why this project? Why is it important? So potential underreporting was identified in a prior study. However, we didn't have the time on that project or the resources to actually investigate why is underreporting occurring. And that's really important to us here in Texas, as well as throughout the United States and globally, because accurate large truck crash statistics are actually really important for our resource allocation and determining countermeasures for protecting the general public. So with a couple projects and one that really said, look, underreporting is occurring, we said, let's figure out why and what can we do about that. So that's what this project sought to do through 3 goals. So first, we wanted to utilize Texas crash data to examine the degree to which large truck crashes are being underreported. So we thought it was an issue. We weren't able to further investigate. So this project really wanted to figure out what extent that is actually occurring. Then we actually wanted to talk with our law enforcement officers, our Department of Transportation, our Department of Public Safety, and other third-party data service providers on potential barriers to reporting large truck crashes. So we have a system in place to report crashes. Is there something in that system that's actually preventing large truck crashes from properly being reported? Then based on the analysis and the feedback from all of the stakeholders, the project next goal is to develop a training and communications plan, as well as tip cards addressing large truck crash reporting specifically for law enforcement officers. So it was quite the project, and with a couple main goals. The first task was to develop a review panel composed of large truck stakeholders to guide the project. This is comprised of people from our DOT, DPS, law enforcement officers, as well as the trucking industry. And we thought it was important to have a diverse review panel available to review our materials, assist with developing the focus group protocols, and all other materials, just to make sure we're not missing something from a research standpoint, since they're on the ground every day. After we had a review panel, we actually did our crash analysis to identify large truck crashes and look at the underreporting, as well as factors associated with that. Next, we conducted focus groups to identify large truck crash reporting barriers with our stakeholders, as previously mentioned. And then the 2 tasks we're currently working on, so this project is still ongoing, it will wrap up this summer, is to develop the training and communication plan, as well as developing tip cards for our law enforcement officers to carry to easily identify large truck crashes to really help address those barriers we've identified. So the next slides, we're going to focus on the crash analysis, then we're going to talk about focus groups, and then how does that actually assist with developing materials and tip cards. So data was collected. We used Crash Records Information System, Texas crash data from 2014 to 2016. We only used a 3-year time period because we wanted the most recent data. So we're not looking at prior trends. We really wanted to account for what's currently going on in the data. Our CMV project definition was a vehicle with a gross vehicle weight rating greater than 10,000 pounds. And so in Texas, for crash reporting purposes, a CMV is a vehicle greater than 10,000 pounds carrying hazmat or 9+ passenger capacity, including the driver. We selected weight based on anecdotal evidence that large trucks typically have significantly different crash reporting barriers compared to other vehicles that meet the passenger and hazardous components of the CMV definition in Texas. So we really wanted to focus just on large trucks being defined by weight. It is important to note if a large truck was carrying hazmat, it was still included. We didn't exclude it. We just didn't look at vehicles that met the requirement just on passenger capacity or hazmat alone. They all had to be greater than 10,000 pounds. So that's a pretty strict definition for CMV. And so to approach that, typically in Texas and other states, CMVs are identified either by a CMV flag. So in the crash data, an officer can check, yes, CMV related. So did it hit one of those 3 definitions? In addition, some researchers and groups use the vehicle body style. And so that's what we approached, was using vehicle body style, because really we wanted to figure out how many times that CMV flag was not being checked. So how many times is it being underreported from law enforcement, but the vehicle body style indicates it is a CMV. So we had 2 classifications for vehicle body. So the first is large trucks. Those include your truck tractors, trailers, semi-trailers, or pull trailers, the ones that obviously hit 10,000 pounds. And there's no question about that. So those are our large trucks. And then our second category that we included in this project are potential large trucks. These are vehicle body styles for trucks, unknown, other C narrative, reported invalid, or not reported. So trucks could include your really large trucks that we see here in Texas, or it could also include some of the larger CMV, well, smaller CMVs that are getting put into truck instead of large truck based on size, but still hit the weight requirement. In addition, we really didn't know what we would see in unknown, others, reported invalid, or not reported, and so we thought we would include them to make sure we're capturing all potential trucks. So the next step we took is we used the Nitsa batch VIN decoder tool. So we have those potential large trucks. We have trucks and unknown and missing. We really don't know what that is. And so we took all of those records that had VINs and we ran them through the Nitsa batch VIN decoder tool. And based on this, we were able to classify our records as CMV, not CMV, and unknown. And so this Nitsa batch VIN decoder is really nice. I don't know if anyone on here has used it, but it's a free tool. It provides information reported on the manufacturer data. So that is a limitation. It's based on reported manufacturer. We won't get any aftermarket changes to the vehicle. But typically if a vehicle leaves, the manufacturer weighing more than 10,000 pounds, it's going to still weigh 10,000 pounds aftermarket. If anything, it's going to weigh more. And in addition, it provides information on body cab type, the gross vehicle weight reported from the manufacturer, make, model, doors, engine information, and fuel information. You also get number of axles, which can be really interesting from research standpoint. So we really had a good experience with that tool. So I'm going to give Nitsa a shout out for that one. So based on using that VIN decoder, our next step was to classify. I told you we classified it, and the figure below I'm going to expand in a minute. But essentially we had 230,000 crashes identified as potentially involving large trucks. Of those, only 76% had a VIN that could be run through the Nitsa batch VIN decoder. So that means that the VIN was not blank. It had something in that field. Whereas 25% were not run through the decoder. These included no VIN, not text.reportable. So we have what we call text.reportable. So if their entry or the cost exceeds a certain amount, they are checked as being reportable, or they were hit and runs. Now hit and runs typically have a lot of missing information because if you don't have the vehicle, you can't enter them into the field. So those We did miss through using the VIN decoder, but at this time there's no technology to really capture those. So this figure here shows the flow of how we approach the VIN decoder and interpreting. So we had 165,000 about that had VINs that could be run. And we classified those into, based on, first we looked at weight. So gross vehicle weight. If our Nitsa VIN decoder showed greater than 10,000 pounds, it automatically went into the green column you see. So we said yes, CMV. And we had a second check before getting to a complete yes, was body class. And so we wanted to confirm, so body class, we included if it was a glider or an incomplete truck. But then if the body class was blank, we said unknown because we still don't really know what that vehicle is. Next, if more than one gross vehicle weight was reported by the Nitsa batch decoder, and some vehicles did have multiple and they fell into different categories, we said those were unknown classification because we don't really know what the gross vehicle weight was. And then if we had an unknown gross vehicle weight, even Nitsa's batch decoder was not able to pull that, we said unknown. And so that all fell into there. And then I should also mention trailers went into unknown because there was only 8 of those, so very low, but that's where they ended up. And then gross vehicle weight less than 10,000 pounds. So if it didn't meet our project definition, we immediately put it into not CMV. And to give a little, another exclusion was if we had body class bus, school bus. So again, those passenger capacity ones that hit weight, but are passenger vehicles. So those were filtered down. So of the VINs that were run through the batch decoder, 32% were classified as CMV based on gross vehicle weight. So that is about 50,000 records that previously we weren't sure what it was, that we now are pretty confident are CMVs. 56.1% were classified as not CMV due to the gross vehicle weight being less than 10,000 pounds, or the body class not being a large truck. So again, our passenger vehicles. And then about 12% were unable to be classified due to missing body information, unknown weight, or being classified as a trailer. Now, of those that were unable to be run through the tool, so remember we had 25% previously that just didn't have a VIN or were hit and runs. Another of these current 4.1% had VIN lengths less than 10 characters. And so VINs after 1981 should be 17 character long. However, antique vehicles, anything older than 1981, would range from 11 to 17. So there is a chance you would have shorter VINs. So we used 10 as our cutoff. So even though there were VINs typed in, they were not complete. And so that's an interesting finding and really shows us the importance of having that information. Okay. So next, we prepared our data for modeling, and there's flow charts showing you how this all happened. I didn't include that today because it's a little bit of a headache, but essentially we had, you remember back from our vehicle body styles, we had our known trucks. So we know that they're large trucks, and our potential. So while we were doing the Nitsa batch decoder, the known trucks were just sitting there waiting for us to identify the trucks. So now with the Nitsa batch decoder, we pulled out all records that were classified as CMV. So all of those in the green bottom CMV box were now put into their own data set, and those were merged with our known trucks from the original start of the project. So now we have one data set, and all crashes in this final data set met the following criteria. So they were TxDOT reportables. They were not identified as a hit and run. Gross vehicle weight greater than 10,000 pounds, which is our project definition. Not vehicle body style trailer. In addition, we went through and excluded pedestrians and bicyclists. There were about 500 crashes total where it was pedestrian or bicyclists that we excluded. We did this because those are going to have significantly different crash factors. And so that's almost a project within itself, is to figure out why pedestrian and bicyclists are being involved in these crashes. And so we really wanted to look at crashes without any other things going on. Okay. So once we had our data, the next step was to model, and so do our advanced analysis. So first we did descriptive analysis and then logistic models. And we broke our logistic models into single vehicle and multi-vehicle. Again, your single vehicle and multi-vehicle crashes are going to have different factors, and we wanted to look at underreporting for both of these together. So our major findings from the crash analysis, we had 89,000 crashes identified as CMV related using body style or the Nitsa VIN decoder. And so using the CRIS flag, so the CRIS flag says CMV yes, no. So the green, the 86.9% were actually properly flagged. However, 13.1% were not flagged. And so that's for all crashes. I think that's really interesting, and so this does show that we see underreporting in our data. Now, once we break it out by single and multi-vehicle crashes, single CMV crashes, we saw a 6.3% underreporting, and multi-vehicle was slightly higher at 14.6%. So we do see differences already between single and multi-vehicle CMV crashes and the degree of underreporting. So again, for underreporting, how we're defining that is if we said it was CMV based on the weight, and then we compared it back to the CRIS classification flag, CMV or non-CMV. And so all of the ones that we said yes, that were not flagged, went into underreporting, and then we calculated percentages. Okay, so that's quite a bit to process, a lot of moving steps in this project. So once we had that, we actually started developing our models and running them. And for both models, so both single vehicle and multi-vehicle, we found license was an important factor that indicated a higher probability of CMV crash underreporting. So specifically, if a driver had a Class C and a Class C plus motorcycle license, these specific crashes had a higher probability of being underreported. And that could be because they don't have the proper license. The officer didn't want to flag them. They were more lenient. We're not really sure what's going on. There's a lot of theories we could toss back and forth. If any of you have any idea to explain that, let me know, because I'd love to hear it. In addition, we found lower speed limits and city streets were also associated with a higher probability of CMV crash underreporting, as well as young drivers. So those younger drivers, for whatever reason, again, were associated with a higher probability of the crash not being reported as CMV. And we saw that across both models. So something to think about. If you guys have any field experience that would explain those findings, let us know. Now, specific to the single vehicle model, we found that hitting a fixed object was also had a higher probability of being underreported just in single vehicle model. And that could be the vehicle ran off, they hit a pole, they hit something small, and the officer, for whatever reason, didn't check it. I, again, don't know, but those single vehicles, higher probability of underreporting if they hit a fixed object like a stop sign, fence, anything like that. In our multi-vehicle model, we had two other factors show up that were, well, four, but I'm going to do the two here. So no injury, and that makes sense because if you don't have an injury, and we found that before, is our fatalities have higher or better reported data, more accurate information compared to our no injury, so that is interesting. And then county roads, again, before we found those lower speed limits for all models, for both single vehicle and multi-vehicle, but for multi-vehicle, we specifically see county roads pop out in the model as having a higher probability of being underreported. Next, the multi-vehicle model, the last findings, we found that certain crash environmental factors, including evening, night, and dark, were associated with a higher probability of being underreported. So that's the really advanced analysis we did. Hopefully I explained it at low level. If not, let me know. And I'll go back through the results because we want to make sure we're getting the information out there. Our next section were the focus groups, our next big task. And so again, the purpose of the focus groups were to talk to our stakeholders. We want to understand what are potential barriers to reporting CMV crashes in Texas. So we specifically had one focus group with CRIS data stakeholders, so that's TxDOT, DPS, all of the people running the database, doing the crash form, as well as some of our larger law enforcement agencies, such as DPS, who are also significant crash stakeholders in the state. In addition to that, we did 5 focus groups throughout the state, and those actually were with law enforcement officers to ask their opinion. What is going on in the field? What do you think from a professional experience? So based on our focus group findings, we found across the board, every single focus group mentioned training was identified as the #1 barrier. So specifically, what is a CMV? There's variations between our state DOT, state and federal definitions, and we had several meetings at the start of this project discussing those variations and how do we define for our project. We went with the TxDOT definition, so how were crashes reported, since we're looking at crash underreporting, but even the state of Texas and Texas DOT don't 100% align. In addition, once you throw in federal definitions, there's some other variations, and so it does cause some confusion. And then in addition, what is the difference between interstate and intrastate commerce? So that's a question we get quite frequently, and how do you explain that simply? So, and how do they identify that for a vehicle? And those were concerns. And then where do they obtain the information for the CMV section on our CR3 form, our crash reporting form? So the crash reporting form has a specific CMV section, has several fields, and that information includes things on the carrier, the gross vehicle weight, things like that, that officers may not be handling on a daily basis, especially if they're in a rural area where maybe they don't see CMV crashes except once every 2-3 years. And we are seeing that, and that came up in one of our rural focus group, that they just don't think they're handling CMV crashes. And so that could be a potential barrier. And then an interesting issue is how to process rental trucks, which we knew from prior work is very interesting. And so like the Penske big yellow trucks, when you're looking at carrier, things like that, how do you actually identify who the actual carrier is? How do you identify some of those other CMV fields that we typically get from the vehicle if it's a rental truck? And so there's a ton of rules on that, and those were some of the big ones. They want training and more information on those areas. In addition, the focus group found that across the board, all our law enforcement officers wanted improvements to crash reporting forms and electronic systems. So specifically, VIN, we talked about that earlier, that we had some VINs less than 10 characters, and there's no VIN, they have to be at least a minimum of 11 characters in length. And so officers, one suggestion for fields like that is having electronic systems say your VIN's too short, because currently the system will take that invalid VIN, and it is something that could be improved with this, I say simple programming change. I'm not a developer, so I don't know how simple that is, but it seems simple, but that's something law enforcement wants. Also for like the TxDOT and USDOT numbers, adding leading zeros was a big interesting suggestion, is they want fields that have leading zeros to automatically do that by themselves. And then promotion of data linkage where feasible. So I know we have individuals from throughout the US and everyone's talking about data linkage and what can you do? How do you get the agreements between agencies? But law enforcement is really calling for that promotion of data linkage within the crash reporting system. So if they have the VIN self-populating the rest of the information, so it reduces what they're having to enter, as well as utilizing other databases that we have here in the state of Texas, from the licensing, vehicle, all sorts of different realms, even insurance information, and actually linking that all together. And #1 goal is to reduce what is being input by officers. And that's interesting because they kept bringing that up as something they want. They want to reduce what they're entering. and reduce the chance of an error. And I understand that. I do data analysis and write all day, and the more I type, the higher probability that there's going to be an issue, right? Higher exposure, higher issue, higher probability of that. So those were the big focus group findings, and those something we're taking, and now we're going to be developing project materials. The materials are going to be actually finalized in about the next 3 weeks. Unfortunately, they were not ready for today. What I can do, again, is I can share them with Robin and Ben, and if they want to email them out, get them out to you. If not, you can reach out to me towards the first week of April, and I can get you those materials. So project materials being developed from the analysis and focus groups. First, we have the training and communication plan. And really our goal there is to help improve large truck crash reporting for law enforcement officers as well as other agencies, and then develop a tip card for law enforcement officers to carry to easily identify large truck crashes and assist with reporting. So first, that communication and training plan that's composed of several different things. So first, we want to develop a communication framework. So how do you communicate CMV reporting as an important issue? How do you identify those audiences and messages that you want to get out? And then we also have a training plan which includes available tip cards, available training opportunities, including the cost, a link to sign up for it, get more information. In addition, we've developed a self-assessment quiz and rubric. And the purpose of the self-assessment quiz is for those officers who say, they're not sure if they need additional training, they don't know what their level CMV, they can do the self-assessment quiz, and based on the rubric, we make recommendations. So maybe the recommendation is to complete training. Maybe it's to go through the CRIS instruction manual for officers, so we have a reporting manual. And so there's a different level of being familiar with CMV. So there's someone that may need full hands-on training and someone who may just need a refresher of material. And then we have performance reporting. So if an agency was going to come in and actually address CMV reporting as a priority, we give them performance reporting measures to actually measure the success of doing those efforts. And so that's the communication and training plan. Right now we're working on making sure it's appropriate for agencies. It's not too research oriented. We don't want it to sound like a researcher wrote it. We want it to be something that can actually be used by agencies in the state. So next we were to design one tip card. However, when we got the analysis and focus group results, it was very hard to pick one topic because there's a need for a whole series of tip cards. So we were able to work it out that this year we're designing 2 tip cards. And these are visor-sized tip cards, which are standard from FMCSA. If we have law enforcement on here, you should get on and look at their law enforcement visor cards they currently have. They're great resources. I keep them in my office. But the first tip card was focusing on identifying CMVs. And this was a specific recommendation from 4 out of 5 of our focus groups, was to actually create a flow chart to assist an officer with determining if a vehicle is a CMV. Now this one does not just focus on weight because that's not beneficial to have out in the field. We did go ahead and add back in the passenger requirements as well as the hazmat requirements. So that flow chart incorporates everything. And so on the front side, they can easily follow a flow chart, figure out if the vehicle is CMV. Next, the back side of that has a table with those definitions for the CMV criteria, as well as instructions on where to find the information. So for example, gross vehicle weight can be found on the registration receipt here in Texas, as well as on the vehicle information plate. And it came out in focus groups that not every officer is aware of that. And so we provide a little tip on how do you get that information and where do you look. The second tip card is identifying responsible carrier and DOT numbers. These came out to be the #1 area that we're seeing missing information when even the CMV section is completed. So even when they say CMV, yes, we still see issues with responsible carrier and DOT numbers. And so again, this has a flow chart to assist officers with identifying the responsible carrier and the DOT number for CMV crashes in Texas. And it directs them on where to find it. And then the second side of that has DOT and other numbers quick reference. And this will tell you basic characters, basic information about the number, and which one should be reported based on priority, based on requirements set forth by Texas DOT. And so it's a lot of information, 2 very small tip cards, and we're hopeful that these will assist officers here in the state in improving reporting of CMV crashes. So do we have any questions today? No, it was quick. It was a lot covered. It's a 2-year project, and I only get a short little break to talk about it.
Thanks so much, Amber. That was a great presentation and a really interesting topic. It's one that we've looked at in Massachusetts as well, and I imagine lots of the webinar participants look at in their state. I have a couple questions while people are thinking of their own questions, and I encourage people to type questions into the chat box or unmute themselves and ask questions aloud. So while people are thinking about that, I'm curious, Amber, about why you didn't use the federal motor carrier criteria for a reportable commercial motor vehicle crash, like not including tows or injuries. Was there a specific reason for that?
So specifically, we were focusing on using the Texas crash data, and that's something that our group specifically uses for CMV research here in Texas. Now, one of the future goals of mine that I've actually noted in I have a future research list, well, it's now a book, but what I want to look at is, do we see differences between the TxDOT data and then the FMCSA data when we start looking at FMCSA criteria and applying it down? And so we used the loosest definition of CMV in the state, which is the crash reporting definition. And really that helps us when we're talking to law enforcement, because law enforcement's not familiar, most of them now, you have your CVE guys who are familiar with FMCSA criteria, but 98% of them only know TxDOT criteria. So that's why we focused on using that.
That makes a lot of sense. Yeah, thanks.
But we do want to look at FMCSA in the future and see how that impacts it.
Uh-huh. It was really interesting to see the differences between lack of reporting on multi-vehicle versus single vehicle. It's not something I would have thought to look at, and really interesting differences.
So our prior research has found in a lot of our various projects that we see different factors for single vehicle and multi-vehicle. I've been told by a couple people they would have expected single vehicle to actually have a higher percentage if it was just a driver by themselves and an officer maybe, you know, felt sympathetic towards them and didn't want to get them in trouble. Uh-huh. Then we saw the opposite with multi-vehicle. Now, I didn't go in with a straight hypothesis because I didn't know what to expect. But vehicle and multi-vehicle play a really important role in the factors we see associated with crashes.
Yeah, really interesting. We have a couple of questions from folks that are participating in the webinar. The first is, how do we get copies of the PowerPoints for the presentation? And I can answer that. We're going to post on the CV-STAC website all of Amber's materials. And she mentioned also offering the copies of the tip cards and stuff. So anything that Amber can provide, we will post on the CV-STAC website for folks to access. We have another question. Is Texas DOT taking steps towards aligning more with MUC variables, which might help streamline the definition more easily? Any thoughts on that, Amber?
So I can't speak 100% to what TxDOT is doing. However, I do know in the past year, we have now started calling our incapacitating injuries suspected serious injuries, which is compliant with MUC. All of our other variables are now aligning more closely with MUC, and I believe that is the goal. I don't know how quick Texas will get there, but we're definitely from a research side seeing small changes that are slowly lining the data.
Excellent. Interesting about the incapacitating injuries. We're in the process of making that same change in Massachusetts. I imagine lots of others on here are too.
Yeah, it's a hard change, especially when you have to talk about them, because I'll be like, I'll talk and I'll be like, oh, suspected serious.
Yeah. We have another question. Were there any inquiries to insurance companies regarding the crashes?
No, we did not meet with insurance companies for this specific project. And so that is something that could be added to try to get additional information.
Okay. Any other questions from participants? Well, Amber, I really appreciate your time sharing everything with us. And Eva, I'm sorry that you couldn't join us, but I've been sick too, so I really understand. It was an excellent presentation, and we will post it on the CV-STAC website so people can get access to it. And Amber will be really interested in hearing about next steps as you continue to work on this.
Yes, and I'll get you those tip cards, so hopefully we can get that out for other agencies, anyone who's interested in using them.
That would be great. I think there will be a lot of folks that are interested in that. For participants, we're really encouraging you to fill out the feedback survey. The website for that is posted in the chat log. It's also posted on the front page of the CV-STAC website. It's really helpful for us to get feedback on what you're finding helpful in the different webinar series presentations and what you're not, so that we can make sure that we're posting information that's the most helpful. So it's really helpful if folks fill that out. Amber, thanks so much again for your presentation. Next week, we have the 5th in the webinar series, and it is on enhanced safety screening for high-risk motor carriers. We encourage people to join us again next week. Thanks, everybody.